Good afternoon, student. I am Professor Dr. D.N. Zambre, Head Department of Chemistry, Kisan Veer Mahavidyalaya, Y. Today, we are going to discuss about non-aqueous solvent like liquid ammonia and liquid SO2. Actually, why we are going to utilize non-aqueous solvent? Because water is called as a universal solvent. Since morning till sleep, we are going to utilize different types of the water. That may be hard water, soft water, distilled water. Number of types of the waters we are going to utilize. But why there is a need to use this particular non-aqueous solvent? Because non-aqueous solvent having typical properties. The boiling point, freezing point, dielectric constant and so many parameters are in negative. And we are unable to maintain such a type of temperature in normal atmospheric pressure, and that's why if you observe that physical properties of acid and bases and non-aqueous ammonia and liquid sulfur dioxide, why this is going to utilize? The first property is liquid ammonia is an inorganic salt. Liquid ammonia is a inorganic salt. If you see, this is the inorganic salt, non-aqueous, protonic and basic natured salt. Why this is called as a protonic salt? Because there is the presence of proton, H plus ion is present. It means if you observe each and every that non-aqueous solvent, there is a proton. That's why it undergoes autoionization and polar in nature. Why this is called as a polar in nature? Polar, it is nothing but there is a formation of positive and negative charges. It means in autoionization what happens? When ammonia combine with ammonia, it is giving rise to ammonium salt. For example, if you see that NH4 plus combined with NH3 combined with NH3, this is giving rise to NH4 plus ammonium salt plus NH2 minus. It means here this undergo autoionization reaction, and due to the autoionization reaction there is a formation of one positive and one negative charge. That's why this is called as a dipole. It means there is a dipole moment can be takes place in aqueous media. What are the solvent character in case of ammonia? Just now I have told that this ammonia combined with ammonia, it is giving rise to NH4 plus and NH2 minus. Here autoionization takes place, and due to this property only we are able to utilize in different research paper as well as in different research field. Then what are the physical properties of liquid ammonia? The first physical property is the boiling point is the minus 33 degrees centigrade. If you convert in the Kelvin, this becomes 240. Then freezing point 195 Kelvin minus 78 degrees centigrade. Then dielectric constant 22 and it is in the Kelvin 240. It means see now here water, normal water having the boiling point is the 100 degrees centigrade. But so many types of the reaction we are going to carry out in non-aqueous solvent like ammonia. It means number of reactions which are impossible to carry out in water, that can be possible in the liquid ammonia due to this physical parameter only. It means here minus 33 degrees is the boiling point. It means how we are going to maintain at normally minus 33 degrees centigrade and minus 78 degrees centigrade. That's why the utilization of non-aqueous solvent like ammonia is most important one. Then next solvent action. It means that liquid ammonia we are going to categorize in different. What are the solvent action? It means if you take halides, salts with poor charge, then ammonium salt, organic compound, then metal ion forming amine and alkali metal ion, alkaline earth metal. It means if you see the periodic table, in that periodic table, the metals which are placed in first A group of element and second A group of element, the halides can be dissolved. It means number of halides also dissolves in For example, if you take alkali metal and alkaline earth metal, if you see the solubility of the alkali metal increases from lithium to cesium. It means if you observe the periodic table, at the top there is a lithium. First A group element if you consider lithium, hydrogen, sodium, potassium, magnesium and cesium. The solubility goes on increases from top to bottom if you observe the group. Then in case of metal ion forming amine complexes like, it means cobalt, nickel, copper, zinc, palladium, platinum plus 2 can form the stable amine complexes. Therefore, salts of such metal ions according to the Levy's acid, they are freely soluble. Why? What Levy's acid says? According to the Levy's acid, the electron deficient molecules are called as a electron deficient molecules are called as Levy's acid. Why? Because they having ability to accept the electron. It means number of metal which is having positive charge, that clear cut indicate that the electron can be easily accessible. It can be easily accepted. That's why this is the Levy's acid. And if there is a presence of Levy's acid, the polar nature can be increases. Positive and negative charges goes on increases. Therefore, the polar nature also goes on increases. That's why metal ion forming amine complex are mostly soluble in liquid ammonia. But it is highly soluble. It is highly impossible to soluble in liquid water. Then if you take organic compound like alcohols, amines, ester, ethers and hydrocarbons and other aromatic compounds such as the liquid ammonia serves as a better solvent for the non-aqueous, non-polar covalent substances. That's why it gets dissolved. Then next one, salts of highly charged ion like oxide, sulfide, sulfate, phosphate, fluoride and carbonate all are insoluble in liquid ammonia. But all these are soluble in water. That's why whatever that water cannot act there, that in place the liquid ammonia plays very important role. Then next, if you see acid-base reaction in liquid ammonia. What is meant by acid-base reaction in liquid ammonia? This is called as the autoionization reaction. NH3 combined with NH3, it is giving rise to NH4 plus. Means positive and negative charges formation takes place. Then in case of this autoionization, amide, imide and nitride formation takes place. In this case, amide, imide and nitride, this plays very important role here. If you see, this is called as nitride, this is called as amide. And another one slide, if you observe, there is a missing one reaction. This is nitride. Another one reaction is amide. Here, suppose if you take NH4 SO4 plus K2 NH2 twice. It means this in this reaction, this is called as amide, this is called as nitride and this is called as imide. Such a type of reactions get carried out in acid-base combination. And what is meant by leveling effect in the liquid ammonia? Leveling effect, it is nothing but suppose one acid is acting as weak acid in water, that acts as a strong acid in liquid ammonia. For example, effect of strong acid, whether that level get maintained or not maintained, this can be explained in this particular leveling effect. For example, if you take effect of strong acid like HNO3, nitric acid, if you take H2SO4, if you take HF, these are the strong acid. This is acting as a strong acid in water as well as it acts as a strong acid in non-aqueous solvent like ammonia. That's why level get maintained. Then effect of weak acid. For example, acetic acid is a weak acid. Acetic acid is a weak acid in water, but in presence of that ammonia, for example, NH3 combined with CH3 COOH. Here what happen? One proton can be easily donated to this one and there is a formation of NH4 plus ion plus CH3 COOH. It means here this is called as a proton donor. It means, this is called as a proton donor because this proton can be accepted by this one That's why the weak acid which shows in water, that can be automatically strong acid in liquid ammonia. And next one, effect of neutral molecule. A neutral molecule like NH2, suppose if you take NH2 C double bond O, and this is the formula for urea. When combined with ammonia, in presence of ammonia, what happen? This one proton can be donated to this one, and neutral ammonia becomes shows the acidic behavior. These are the some effects of the leveling parameter in case of ammonia. Thank you.